In this video, I am going to discuss about Chapter 1 Real Number Exercise 1.1. In this exercise, first question is linked to prime factorization. Observe, I am having 3 questions of this exercise. First question is linked to prime factorization. What is the first question? Observe, express each numbers as a product of its prime factors. हमें each number को, we are having 5 numbers are there and we want prime factors of these numbers. तो हमें क्या करना है, इन 5 क्वेश्चंस का प्राइम फैक्टर्स निकालना है. जो हमारी फर्स्ट एक्सरसाइज 1.1 of this chapter, in which we want prime factors. What we want? We want prime factors. We want prime numbers. So finding of prime numbers of these numbers, what method we are using there? That is the prime factorization method. So starting of prime factorization, first I want to explain prime number and composite number, in which one word we are using, prime numbers. So what about the prime numbers? We must know this thing, then we can understand this topic. So prime numbers are what? The counting numbers which are having 2 factors. What? Counting numbers which are having 2 factors. What I am discussing? क्या पढ़ रहे हम? Prime numbers. तो what about the prime numbers? Counting numbers. Prime numbers क्या होते हैं? Prime numbers are counting numbers and which are having 2 factors. Those counting numbers. Now first understand what about the counting numbers. Counting numbers are those which are countable. I am having marker. How many marker I am having? That time I am having 1. Now how many markers I am having? 2 markers I am having. It means 2, 1, 2. These are what? Counting numbers. And these numbers 1, 2, 3, 4, 5 and so on. These are called counting numbers. And counting numbers are what? Natural numbers. So prime numbers are what? Counting numbers. Counting numbers होंगे which are having 2 factors. वो counting numbers जिनके 2 factors हो. So what about the prime numbers? Counting numbers which are having 2 factors, 1 and itself. 2 factors, 1 and itself. वो counting numbers, वो natural numbers, those numbers which are having 2 factors, 1 and itself, are called what? Prime numbers. Examples of the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19 and 23 and so on. Smallest prime number is 2. What is this? 2 is the smallest. सबसे छोटा जो prime number होगा वो है 2. Now what about the 1? 1 is neither prime nor composite. So smallest prime number is what? 2. Now how they are prime? I am just explaining there. 2 is the smallest prime number. And what is the definition of the prime number? Having 2 factors, 1 and itself. Now what are these factors? It is divisible by 2. 2 is divisible by 2 only, and 1. So we can say 2 and 1 are the factors of 2. Now 3 and 1, 5 and 1, 7 and 1 and so on. But which are not prime, those numbers, those counting numbers which are not prime, called composite number. Like 4. What about the 4? 4 equal to 2 into 2 into 1, 6, 2 into 3 into 1, 8 2 into 2 into 2 into 1. So these numbers are 9. What about the 9? 3 into 3 into 1, like this. So these numbers are having more than 2 factors. If numbers are having more than 2 factors, those counting numbers are called what? Composite number. Getting or not? What I am explaining? I am discussing about the prime numbers and composite numbers. Why? In the exercise 1.1, first question is linked to prime factorization. We want prime factors of some numbers. So for getting prime factors, first we must understand the prime numbers and composite numbers. So prime numbers, counting numbers which are having 2 factors, 1 and itself. Smallest prime number is 2. 1 is neither prime nor composite. So these are the examples of the prime number. But those numbers which are not prime called composite number. Those counting number, those natural numbers which are not prime, 2 is the prime, 3 is the prime, 4. Now in between with 3 and 5 we are having one counting number 4. 4 is the composite number. Why? It is having more than 2 factors. So I hope you are getting what I am saying there. So I explained the prime numbers and composite numbers and what is the difference between both. Now I am going to start the question number first one. Then we want the prime factor there. So just by using long division method. What method we will be used there? Long division method. We will find the prime factors of the number. So first question I am taking there. What is the first question? I am having one number. What is the number? Question number first one. And first 140. 140 is there. I want its prime factors. What I want? I want its prime factors. So do by using long division method. 140. Now this is the division method I am using there. 140. Now we want what? Prime factors. हमें क्या चाहिए? Prime factors चाहिए. So we will use prime numbers. First we use smallest prime number. And smallest prime number is what? 2. So first we use 2 to divide this number. And what is divisibility rule of the 2? What is divisibility rule of the 2? If unit place, ones place of the number. Observe, this is the number and this place is called what? Ones and unit place. If ones and unit place is having 0, 2, 4, 6, 8, then that number is divisible by 2. Again I am saying what? If number having unit place 0, 2, 4, 6, 8, then that number is divisible by 2. Now 140, this number having unit place 2, so we can divide by 2. I am using 2 there. How many times it is going? 70. Now 70. Again 70 having unit place 0, so we can divide by 2. Now dividing this one, how many times it is going? 3 times, 1 is remaining. 5 2 ja 10, 35. Now we are having number 35. So can we divide this number by 2? No. Why? This number having 5 on the unit place, and for 5 is not in these numbers. For divisibility of 2 is that unit place having 0, 2, 4, 6, 8. Now next prime numbers we will be used. Now next prime number is what? 3. Next prime number is what? 3. Can we divide this number from 3? So for dividing this number by 3, first we know the divisibility rule. What? First we know the divisibility rule of the 3. And what about the divisibility rule of the 3? For the 3 divisibility, we will sum the digits of the number. We are having 35 and sum of its digit will be what? 3 plus 5, and 3 plus 5 will be what? 8. Now observe, once sum of digits of the number is a multiple of 3, 8 is a multiple of 3. Multiple of 3 means what? Having like this, 3 having in a table of 3, 3 1 ja 3, 3 2 ja 6, 9, 12, 15, 18, 27, 21. These are the what? Multiple of the 3. Or we can say, if number is divided by 3, then we are getting remainder is equal to 0, then we can say that is divisible by 3. अगर हम नंबर के डिजिट्स को सम करने के बाद जो नंबर आता है उसको 3 से डिवाइड करने पर रिमाइंडर अगर 0 आ रहा है तो हम कहेंगे that is divisible by 3. Now we are having 8 and 8 is not multiple of 3, then we cannot divide by 3. So next prime number will be used 5 1. Now what is the divisibility rule of the 5? For the 5 unit place, if unit place having 0 and 5, if unit place is having 0 and 5, then we can divide that number by 5. But we use this 0 there, so if we are having unit place 0, then we already divided by 2, so only we observe if unit place having 5, then we can divide by 5. अगर unit place पर 5 होगा तो हम 5 से divide कर पाएंगे. 0 we used in a 2 divisibility. So first, if what is the 2? If unit place having 0, 2, 4, 6, 8, then we will divide by 2. For the 3, sum of the digits of a number, if multiple of the 3, then we can divide by 3. But for the divisibility of the 5, if unit place is having only 5, if unit place is having 5, then we will divide by 5. So this number having 5, so we can divide this number by 5. How many times it is going? 7. Now 7 is a prime number, and prime number is having 2 factors, one in itself, and this number is divided by only 7, so we will use 7 like this. Now 140 can be written as 2 into 2 into 5 into 7, and finally we can say in the exponent form 2 power 2 into 5 into 7. Once we multiply these numbers, then we are getting 140. How? 2 2 ja 4, 4 into 5, 4 into 5, 5 4 ja 20, and 27 ja 140. So these are the prime factors. 2 into 2 into 5 into 7 are the prime factors of 140. So what about this question? Express each number as a product of its prime numbers. So we expressed 140 in the prime numbers form. 140 having 2 into 2 into 5 into 5. So we express this number there. So this is the answer of this question. Now next question I am taking there. What is the next question? Now I am taking next question. Question number first, second one, and this one is what? 156. 156. Again, by using prime factorization method, using long division method, 156. Write like this. Now unit place 6. Unit place is 6, and if unit place having 0, 2, 4, 6, 8, then we can divide by 2. So this number can be divided by 2. How many times it is going? 7 times. Now 1 is remaining, 8 times. Now next number is 78. Unit place is having 8, so this number is divided. 8 is in this, so it is divisible by 2. Writing 2 there. How many times? 3 times. 1 is remaining, 9 times. Now can we divide 39 this number by 2? No. Why? Unit place is having 9, and 9 is not in these numbers. So we will use next prime number. And what about the next prime number? 3. 3 is the next prime number. So I am dividing by 3. 1 For dividing by the 3, what is the rule of the 39? 39, for dividing of 3, first sum of these digits of this number, 3 plus 9, and this is 12, and 12 is a multiple of 3, 3 into 4, this is the 12. So this is the multiple of the 3, so we can divide by 3 one time and 3 times. Can we divide 13 to any number? No. Why? Because 13 is a prime number, and prime numbers having only 2 factors, 1 in itself, so it will be divided by 13 only. So in this way we are getting factors of 156 equal to what? 2 into 2 into 3 into 13. So finally we can write like this, 2 power 2 into 3 into 13, and this is the solution of or prime factors, prime numbers of 156. I hope you are getting this process easy. So we expressed 156 in a prime numbers form. Now next question I am taking there. So next question is what? Question number 3. Question number 3 I am taking. What is the question number 3? 3825. Question number 3. 3825. Again using long division method, 3825. Now can we divide this number by 2? No. Why? Because unit place is having 5, so we cannot divide 2. If unit place having 0, 2, 4, 6, 8, then only we can divide by 2. Then we will use next prime number, and next prime number is what? 3. For dividing of the 3, first we will add the digits of the number. We are having 3825, and its digit sum 3 plus 8 plus 2 plus 15 will 5 will be what? 8 plus 2 10, 10 plus 5 15, 15 plus 3 18, and 18 is the multiple of 3. How? 3 into, it is coming in the table of 3, 3 into 6, 6 3 is 18, it is a multiple of 3, so we can divide this number by 3. I am using 3 there. 1 times, 2 times, 2 is remaining, 6, so 2 is remaining. How many times? 7 3 is 21, 1 is remaining. 5 times it is going, 5 3 is 15. Now again use first 3. So for dividing of 3, we will sum the digits of the number 1 2 7 5, and sum will be what? 1 plus 2 plus 7 plus 5. So this will be 7 plus 2 9, 9 plus 1 10, 10 plus 5 15, and 15 is the multiple of the 3. 3 into 5 we can getting 15, so it is the multiple of 5. 3 multiple of 3, so we can use 3. Dividing 3, how many times it is going? 3 4 ja 4, 3 ja 12, 2 times, 1 is remaining, 3 5 ja 15. Now I am having 525. Again check, is it divisible by 3 or not? 4 2 5, 4 plus 2 plus 5, 4 plus 5 9, 9 plus 2 10, and 11, 6 plus 5 11, and 11 is not multiple of 3. We cannot use 3. It is not multiple of 3. So now next prime number is what? 5. We will use 5, and divisibility of 5 is that unit place is having 5, then we can divide that number by 5 easily. So we will use 5 there. How many times it is going? 8 times. 8 5 is 40, 2 is remaining, 25. Now how many times? 5 5 is 25, 85. Again, now not necessary to check 3 and 2. It means after this one, this number will be divided by 3 or more. So unit place is having 5, so we will divide this number by 5. How many times? 1 times. 3 is remaining, 5 plus 3 8, 3 is remaining, 35. How many times I am going this one? 7 5 ja 17, 7 5 ja 35. So 17 and 17 is a prime numbers, so it is divisible by itself. 17, how many times? 1. So prime factors of 8325 will be what? 3 into 3 into 5 into 17, and this can be written as 3 square into 5, 3 square into 5 into 17, and this is answer of this question. Now next one, question number 4th one I am going to solve there. And how we will solve this question? Observe this one, easy question. Question number 4th one of question 1, 5005. This is 5005. So for finding prime factors, prime numbers, we will use long division method. So using long division, 5005 is there. Now observe, can we divide this number by 2? No. Why? Because unit place is having 5. If unit place is having 0, 2, 4, 6, 8, then we can divide by 2. Then next prime number is 3. Can we divide this number by 3? No. Why? Because sum of these digits, 5 plus 0 plus 0 plus 5 is 10, and 10 is not multiple of 3, so we cannot use 3. Now next prime number is 5, and divisibility of the 5 is what? If unit place is having 5, so it is having 5, so we can divide this number by 5, and this is the division. How many times? 1, 0, 0 and 1 will be the division of 5005. Now 1005. Can we divide this number by 5? No. Next prime number is what? 7. I am using there. Now how many times it is going? 1 time. 3 is remaining. Now how many times going? 30 is there, so 4 times. 7 4 are 28. Now 2 is remaining, 21. Yes, we can divide easily. 7 3 are 21. Yes, it is divisible by this number. 1001 is divisible by what? 7. Now next one, 143. Can we divide this number by 7? Check this one. I am using 7 there 2 times. Now next, so we cannot divide this number by 7. Next prime number is what? After 7 we are having 11, so we will use 11 there, dividing 1 times. What is the remaining? 3, 33, and it is the multiple of it is in the table of 11 3 times. So yes, it is divisible by 11. Now 13 is the prime number, so it is divisible by itself 1 time. So prime numbers of 5005 will be what? 5 into 7 into 11 into 13, and this is the answer of these questions. Are you getting what I am saying? I am doing long division method to find the prime numbers of these numbers. Okay, completed 1, 2, 3, 4 questions. Last questions is there. And what about the last questions? I am going to do last questions, 5th one of first question of exercise 1.1 I am taking there. And in this 10th standard, this exercise is important for the board exam point of view, and we can know these concepts well. So question number 5 I am taking 7429. 742. First observe carefully. If you change one number, then answer will be wrong, and we cannot having problem there. So what is the 5th question? 7429. Use long division method. 7429. Again, each prime numbers, apply each prime numbers to check of divisibility. Can we divide this number by 2? No. For 3, I don't know. Sum of digits is multiple of sum of digits of this number is multiple of 3, then we can say divisible by 3. So add these numbers. 7 plus 4 plus 2 plus 9. 7 plus 4 11. 11 plus 9. 11 plus 9 20. 20 plus 2 21. Not 21. 7 plus 4 11. 11 plus 9 20. 20 plus 2 22, and it is not multiple of 3, so we cannot use 3 there. Now next prime number 5. Can we divide this number 5? No. I can easily say what? If unit place is having, then we can divide by 5, so we cannot use 5 there. Now next prime number is what? 7. Can we divide this number? Can we divide this number by 7? Just try to solve. Can we divide? Yes, I am just checking from table. Above this, no necessary to memorize the divisibility rule. Use numbers, use prime number 7, 11, 13, 17. Divide if they are divisible, they are dividing, we are getting remainder 0, then we will do. Otherwise, we will apply next prime numbers. So I am using 7 there. How many times it is going? 1 times. Next one, 4 not divisible. How many times it is going? 7 4 7 7 7 ja 49 and 7 6 ja 42. 6 times it is going. And now next one is the one time. Something we are getting, remainder is not 0, so we cannot use 7. Now next prime number I am taking there 11. Can we divide this number by 11? Next prime number is 11. How many times? 6 times. 11 6 are 66. 11 7 are 77, more than this one, so we cannot use. 6 times. What is the remaining? 66. 4 plus 4 8. 8 is remaining. Now 82. So how many times it is going? 7 times. Now 82 minus 77, we are having 5. 59. It is going 5 times. 4 is remainder. It is not terminating. So remainder is not 0. We cannot use 11. So now use next prime number. And what is the next prime number? 13. Yes, for divisibility of 13, first we know the table. Then we can divide easily. 13 5 ja. 13 5 ja. What is the 13 5 ja? So 78. Not 78. 13 1 ja 13. 13 2 ja 26. 13 3 ja 39. 13 4 ja 52. And 13 5 ja 65. 13 5 ja 65. 13 5 ja is 65. And it is more than 65. 13 7 ja. Not 13 5 ja. 13 5 ja is what? 65. 13 5 ja is 65 ja. 65. And 13 6 ja. 13 6 ja 78. 78. So we cannot use 6. It is going 5 times. 5 times 65. 13 5 ja is 65. 65. 74 minus 65. 74 minus 65. What is the remaining? 14 minus 4 9. 14 minus 4, not 4. 14 minus 5, we are having 9. And there is a 6 0. Only 9 is remaining. So 9 is there. Now 92. 92. In the table of 13, we are having 92. No. But we are having 91. How many times? 13 7 ja. 13 7 ja. 13 7 ja, we are having 91. 7 times it is going. 1 is remaining. 92 minus 90. 92 minus 91 is 1. So 1 we are having. Now this is 19. It means what? We cannot divide 19. 19 is a prime number. We are not getting remainder equal to 0. So we cannot use 13. We cannot use 13. Using next prime number 17. Next prime number is 17. Next prime number is what? 17. Now 17 3 ja 51. 17 3 ja 51. 17 4 ja 68. 17 4 ja 68 and 17 5 ja 85. 17 5 ja 85. 17 5 ja 85. So 17 5 ja is more, so we will use 4 times. 17 4 ja 68. 17 4 ja 68. 68. 74 minus 68. What is the remaining? 14 minus 8 6. There is a 6 6 0. Only 6 is remaining. 6 we will be put there. Now 62 dividing by 17. How many times it is going? So 17 3 ja 51. 73 ja 51. And we are having 62. 17 4 ja 68, more than. So we will use 3 times. 3 times it is going and coming 51. 62 minus 51. What will be the remaining? 1 and 1 11. Yes. 17 4 ja 68. Remaining is 6. 6 we are putting 62. Now dividing 17 3 times. 51. Remaining is 11. 119. And in the table of 17, when we are getting 119, 17 7 ja 17 7 ja or 8 ja 17 7 ja 17 7 ja 119. 17 7 ja 119. So it is divisible by 17. So this number 7429 is divisible by 17 prime number. Again I am showing 17 4 ja 68. Remaining is 6 62. So 17 3 ja 51. Remaining is 11 119 and 17 7 ja 119. Yes, getting? Now can we divide this number by 17? Use 17 again. 17 2 ja 34. We cannot use 3 times. 17 3 ja 51, more than. So 43 minus 17 2 ja 34. What will be the remaining? 9 and 1 19. 19 is remaining. It is the 19 is remaining. Not possible. 9 is remaining. 9 is remaining. 43 minus 34 9. This is a 0. Clear? 9. Now next 9 is there. 97. 97 is in the table of 17? No. In the table of 17 we are having 85. 17 8 ja 85 and 17 6 ja 102. 17 6 ja 102. So we cannot divide this number by 17 now. So then we will use next prime number 19. Use 19. 19 2 ja 38. Remaining is 5 and 19 3 ja 57. Yes, it is divisible by 19. Now 23 is the prime number and it is divisible by itself. So these are the factors of this number. So we can say 7429 can be written as 17 into 19 into 23. So this is the process for finding the prime numbers of these numbers. For finding the prime numbers of these numbers, first we use the long division method and we will use smallest prime number first, 2, then 3, then 5, 7 and so on. So I explained each questions of this question. Now I am going to explain next question number 6th one of your this exercise. So what about this question? Observe. Now explanation I am giving there. What is the question number 6 of exercise 1.1? Observe. What is this question? Explain why two numbers are two product and sum. We are having two numbers. Explain 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. We want to show composite number. These solution of these two numbers. Once we solve this, then we are getting a number and that number is composite or not. I want to check. For checking this, is this question having two question? One is this one and another one is this one. One by one I am taking there. So question 6th one, first one. What is the question? 7 into 11 into 13 plus 13. 13 plus 13. Now observe this question. What is happening there? This is a product of three numbers, 7 into 11 into 13, then we are adding this one. But for solving this question, first we know the board mass. What about the board mass? Board mass. And board mass is saying what? First we solve the bracket, then off, then division, then multiplication, then addition and then subtraction. So in this question we are having product and addition. So for solving these questions, first we will solve the product, then whatever result will be there we will add. We cannot do directly this one addition. No, first if we do the first addition, then our answer will be wrong. So first in the like these questions, if you are having different signs, product, division, addition, subtraction and bracket, then first we will solve by using board mass, bracket, then off, then division, then multiplication, then addition and subtraction. In these questions we are having multiplication and addition. So multiplication having first and then we will do what? Addition. So we will use first multiplication and then add number. So for clarity we can use bracket there. First we will use what? Multiplication. Then whatever result we will add. Multiply this one. 11 7 ja 77 into 13. We will multiply first, then add this one. First multiply this one. 13 7 ja. I am multiplying 13. We know well the table of 13. 13 7 ja. What is the 13 7 ja? 91. 13 7 ja is 91. So we will put 1 there. 9 is remaining. 13 7 ja 91. 91 plus 9 we are having 100. So this product will be 1001. Then we will add 13. So we are getting 1014. 3 plus 1 4, 1 0 and 1 this. So this product and addition solution will be what? 1014. Now we want to check, explain why this is composite, why this number is composite. So we are getting this number, how we are getting? In the product and addition, first we will do the multiplication, then result will be added to 13. We are getting this number. I want to check this is the prime number or composite. This is the composite. Explain why this is the composite. We want to explain why this one is the composite. So for explaining this, first we do the prime factors by using long division method. What number we are having? 10. We are having 1014. Result of this 1014. Yes, this is divisible by 2. Yes, having unit place 4. How many times? 5, 0 and 7. Can we divide this number to? No. Again, next prime number is 3. 7 plus 5, 12, and 12 is the multiple of 7 plus 5, 12. 12 is the multiple of 3. We can use 3 there. How many times? 1 times. 1 times how many numbers are remaining? 2. 20. Now how many times it is going? 6 times. 6 3 is 18. 2 is remaining. 27. How many times? 9 times. 9 times it is going. So now we are having 169. Now is it divisible by 3? 9 plus 1 10, 10 plus 6 16, and 16 is not a multiple of 3. We can not use 3. Can we divide this number by 5? No. Unit place having 9. If unit place is having 5, then only we can divide by 5. Next 7. Use 7. How many times? 2 times. 7 2 ja 14. 2 is remaining. 7 2 ja 14. 2 is 16 minus 14. 2. 2 is remaining. 29. It is not in the table of 7. So we cannot divide by 7. Now next one 11. Can we divide 11? How many times? 1 times 5. No, we cannot divide by 11. Next prime number is 13. Use 13. 1 time it is going, 3 is remaining, and 13 3 ja 39. Yes, we can divide by this number by 13. So we can say again we will use 13 and this one. So this number 1014 is the result of these numbers, and we are getting factors of 2 into 3 into 13 into 13, and these are the more than 2 numbers. This number is the product of more than 2 factors. So we can say this is a composite number. This number is a product of more than 2 numbers. So we can say what? This is a composite number. Getting or not? First solve this number. Whatever result we are getting, do the prime factorization, and if prime factorization of that number is having more than 2 factor, obviously by observing we can say it is having more than 2 factor, so it is not prime number, it will be what? Composite number. So this is the solution of this question. Now I am going to do the next question of this question. And what is this one? Observe, second question is given. In this question is that one series of the product and plus is given. First solve this one, then conclude. What is the second one? 7 into 6 into 5 into 4 into 3 into 2 into 1 to 7. Add 7 6 5 4 3 2 1, then add 5. So same we will apply the board mass, and board mass is saying first do the multiplication then add. So first we will do the multiplication. So do multiplication. 7 into 6 5 ja 30 into 4 3 ja 12, and 12 2 ja 4 3 ja 12, 12 2 ja 24, and 24 into 1 24. So this is the product of 7 into, we are multiplying both, and we are multiplying these all. 6 5 ja 30, 4 3 ja 12, 12 2 ja 24, 24 into 1 24. then we will add 5. Do first this multiplication. I converted these product in only 3 numbers of product. So this is the multiple of 10, so we can easily multiply what, how? 7 3 ja 21 into 24 plus 5. Now do this multiplication. I don't know, do like this. To multiply by 24 into 21, we will put 0 directly. How many times? 4 to 8, 2 to 4, 4 10 0 1 5, and put 0. What? 5040. With this 0 will be there. We are getting product of 24 into 21, this one 504, and this will be 0 will be this there. Then add this one. What we are getting? 5045. Now by observing we can say it is having more than 2 factors, so this is not prime. This will be what? Composite. Just do the prime factorization. Just do the prime factorization. Do the prime factorization of this number. 5045. It is divisible by not 2, not 3. Sum of these numbers, 5 plus 5 10, 10 plus 4 14. It is not multiple of 3. Now next 5. Yes, even place having 5, we can divide this number by 5. 1 times 0 0 and 9 times 1009. Now for this number is not divisible by 2 3 5 7 11 13 17 19 23 and so on, but it is a prime number and it is directly divided by this itself. We are getting this one, so we can say 5045 having more than 2 factors, 5 into 1009 into 1. So this is composite number. Composite number. If numbers are having more than 2 factors, then we can say composite number. So in this way we solve these 2 questions of question number 6. Now I am going to explain question number 5. And what is the solution of this question? Observe this question. This is the logic based question, and in this question, what is the question? Check whether 6 power n can end with the digit 0 for any natural number. This is the concept based, logic based question, and what we want? We want to check whether 6 power n can end with the digit of end with the digit 0 for any natural number. Observe, logic based question, easy question. Observe what will be the solution of this question. Check whether 6 power n can end with the digit 0. We will solve, we will observe for any natural number. N is any natural number. N is what? Any natural number. We are having question 5, 6 power n, and in which n is the natural numbers 1 2 3 4 and so on. Okay, when we put n equal to 1 2 3 4 5 and so on, then what we are getting? Observe, n equal to 1, we are having 6 power 1, result is 6. n equal to 2, we are having 6 power 2, 6 into 6, result will be 36. n equal to 3, 6 power 3, it is having 6 into 6 power 3, 6 into 6 into 6, result will be 200 what? 216. 216 will be the result. 216. Now n equal to 4, 6 power 4, 6 into 6 into 6 into 6, 4 times. Multiply 216 multiply by 6, how many times it is going? 6 6 ja 36, 3 is remaining, 6 ja 1, 6 1 ja 6, 6 plus 3 9, and 6 2 ja 12, 6 2 ja 6 times 3 is remaining 9, 6 2 ja 12, 1296, 1296, 1296 and so on. Now what we are doing, once we put n equal to any natural number 1 2 3 4 and up to infinity, If we put any natural number there in the place of n and then solve that number, then we are getting 6, 36, 216, 1296. Tell me, any number is ending with 0? Can end with the digit 0? Can end the digit 0? Observe, any number after putting the natural number values 1, 2, 3, 4 and so on, we are getting ending with 0? No. Ending with 0 means what? 20, 10, this one, 81. These numbers are ending with 0. Any number is having these types? No. So, we can say what? Check whether 6 power n can end with the digit 0. No. No. By this calculation, what we can say? No. 6 power n cannot end with digit 0. So, directly we can say when number will be end with 0? If we are having like this number. And the factors of this number, I am taking 20. What about this prime factors of this number? Dividing by 2, 10 times. Again dividing by 2, 5 times. It means 20 is having 2 into 2 into 5. It means 2 power 2 into 5. Clear? If number is having, you can solve these number, find the prime factors, you will get 5. If number is having factor 5, then we can say that number will be end with digit 0. But these numbers, I am trying to solve prime factors of these numbers. 6. What is the prime factor of 6? 3 times 1. So 6 having 2 into 3. Now next one, 36. 36 prime factors. 18, 2, 9, again 3. 3 and again 3. So this is having factors what? 36 having factors 2 into 2 into 3 into 3. It is having 2 into 2. Similarly this one. What are the factors of 216? I am just doing there factors of 216. 216 divide by 2, 1, 0, 8, again 2, 5, 4, again 2, 2 and 1 is remaining, 7, again now 3, 9, 3, 3 and 3. So this is having factors what? 2 into 2 into 2 into 3 into 3 into what? 3. So this number 216 having this one. This can be written as 2 power 2 into 3 square. This can be written as 2 power 3 into 3 power 3. Similarly, we can do this number also. So what is happening? 6 power n, once we put values of natural number 1, 2, 3 and so on, we are getting factors, and these factors, what about this? 2 and 3. 2 into 3 and 2 power 1, 3 power 1, not 2 into 2. 6 having the how many? It is divisible by 3. 2 3 times 1 times, and it is divisible, its factor is having what? 2 into 3. These numbers 6 power 1, 6 having 2 into 3, 6 power 2, 36 having 2 power 2 into 3 power 2, and 216. This number, when we put n equal to 3 in this question, in this number, then we are getting 2 power 3 into 3 power 3. 2 2 ja 4, 4 2 ja 8, 3 3 ja 9, 9 3 ja 27. We will multiply 27 into the 8, then we are getting 216. So factors of these numbers, we are having multiple of 2 and 3. If we are having 6 power n, putting value of n equal to 1, 2, 3 and so on, put any value, you will be get factors of 2 and 3 through 2 and 3. In the factors you will be get 2 and 3. But if number ends with 0, 20, 10, 100, 80 and so on, these types of the numbers, and we do the factors, and in these number factorization we are having 5 as a one factor. In these numbers we are having 5 as a one factor, but in this number we are having 2 and 3 as a factors. So we can say what? 6 power n cannot end with 6 power n cannot end with digit 0, cannot end with digit 0. Why? Because it is having prime factors 2 and 3, and with 0 then number must have factor 5. So this is the solution of and best explanation of these questions. So I hope you are observing and getting solution of these questions. So today what we studied, I am going to explain 1 to 2 minutes. So listen carefully. We started with chapter 1, real number. I already explained the introduction of the numbers of this exercise, this chapter, and today I started with prime factorization. Today I started exercise 1.1 and it is based on the prime factorization, and we are having 1.1 exercise there, and out in this exercise some questions are there. Out of these questions I solved 3 questions, question number 1, question number 5 and question number 6, and in the question number first, in these all questions we require prime factorization, prime numbers. So prime numbers are having 2 factors, one in itself. Those numbers which are not prime called composite numbers, like 4, 6, 8, these are what? Composite numbers. Smallest prime number is what? 2. One is neither prime nor composite. Neither prime nor composite, we can say. Now in the question number first, prime factors we want, do the division method and we can find. In the next question, in the question number 7, multiplication and positive plus series is given. First we will using board mass and do the multiplication, then add the number. Similarly we will do this one, we will getting the number after solving, and then we will find the prime factorization. And if number obviously more than 2 factors we will get, and then we can say what? Composite number. Clear? And in the question number 5 we checked 6 power n never ends with 0, because 6 power n, when we put any value of natural number 1, 2, 3, we are getting factors of 2 and 3. Never end with 0. Number ends with 0 if one factor is 5. Like 10, it is having 2 into 5. So it is not having 5, so it will never ends with 0. So I hope you understand all things. That's all about this exercise. Thank you so much.